our second attempt at having her here, and unfortunately it couldn't have happened in person, but we're still feeling very lucky that she's here. And this event is being hosted by the EMBS, IEEE EMBS student chapter at UIC. And the board is here, the only people with their cameras on. And they specifically, Haley, has worked very hard in order to organize this. So I'm just going to pass it on to Haley to introduce Dr. Moussavi.
Thank you, Dr. E. Hi, everyone. So this is our third installment of the IEEE EMBS Distinguished Lecture Series here at UIC. We are super honored to have someone as esteemed as Dr. Moussavi speaking with us today. And I know, Doctor, thank you for taking time out of your schedule to do so. Now, for those of you who don't know, Dr. Moussavi is the founder and the director of the Biomedical Engineering Graduate Program at the University of Manitoba. She's also a professor there. So her research deals with a variety of things. She covers medical device instrumentation, she covers signal analysis for sleep apnea management, and then, of course, she talks about the diagnosis and treatment of Alzheimer's using virtual reality, rTMS, TACS, and a variety of other technologies. She has published 270, I believe, or a little bit more than 270 peer-reviewed papers, and then also given 2 TEDx talks. So today, give me one moment. I will share this. Perfect. So today, Dr. Moussavi is going to be talking about the non-pharmaceutical treatment of dementia, including rTMS and TACS, as well as both with and without cognitive exercises. And we are fortunate enough, I believe you're mentioning some of your pilot studies from your current clinical trials, right? Wonderful. And then before we begin, just a couple things I want to go over real quick. So as you guys can see, everyone is muted, and we'll be taking questions at the end of the presentation. So anytime throughout her presentation, if you have any questions, just send it in the chat. Both, well, me and the other board members will be monitoring it throughout the presentation. And then once the presentation is over, again, me and the other board members will be reading the questions. During that time, feel free to raise your hand if you rather ask the question yourself. I'll just unmute you and you can do so. Another thing I want to talk about is that this lecture is recorded, and once the lecture is over, I promise sometime after I will be sending out a link to everyone who has registered. Likewise, in the chat after the presentation, I'm going to throw on this link right here, which is a link to her current research page, just in case anyone wants to read a little bit more about what she's been doing. And I think that is everything I wanted to touch on real quick. So Dr. Moussavi, you are a co-host rather, so I believe you should be able to share your screen. I'm gonna stop sharing mine, and then you can begin whenever you would like.
Sure, let me share it first. Yes. Okay, I suppose you see the slideshow, correct?
Mm-hmm.
Not the presenter view. Okay.
Yep.
Hello, everyone, and thank you very much, Haley, for your introduction, and thank you for inviting me. Yeah, I was supposed to be there in March in person, but due to COVID, everything is virtual. Anyway, I always love to talk to students because that is always inspiring for me, and I enjoy seeing young, enthusiastic, passionate faces, basically. Okay, today's talk is going to be about non-pharmaceutical treatment of dementia, just an overview, a quick overview, and I will go over a number of pilot studies, as Haley said. I do very well know that the attention span of people, the students in general, is about maximum 7 minutes. So every 7 minutes, I have to do something so that you don't fall asleep or feeling bored or not paying attention. It's like giving a very boring lecture. So if at any time, if you feel bored, just raise your hand, ask a question. It doesn't matter. You can even ask in the middle of presentation. That's fine with me too. Okay, with that intro, let me start. Okay, first of all, about Alzheimer's. I believe Alzheimer's disease, which is a type of dementia, is a thief. It is coming and stealing the most precious memories that people identify themselves with. It is a very clever thief indeed, because people who are affected by the Alzheimer's, they don't even know what they have lost. They generally feel lost in time and space. So for me, the first when I started this research in this area, which was quite a personal connection to it, because my mother got Alzheimer's, for me was the main question was that, is there a way that we can slow the progression of the disease? And secondly, is there a way that we can change with a healthy brain? I must tell you that I always live with that fear that one day I may get Alzheimer's too, because as I said, my mother had, my great aunt had, my great grandma had it, and therefore I may have a gene and develop Alzheimer's sometime too. Is there a way to age with a healthy brain? Well, there are medications. So the question is, do they help? And there are non-pharmaceutical treatments. By the way, medication types are not that many. They are mostly cholinesterase inhibitors. All of them are from the same family. Non-pharmaceutical treatment, there are a number. For example, there is rTMS, there is TVCS, TACS, there is transcranial electromagnetic treatment, cognitive exercises, music, physical therapy. And the main question again is that they all claim, all of these have had pilot studies. So far, there is no large clinical trial that can prove any of these are effective or not. So the main question is that, are these all fiction or fact? Is there any real benefit to the people? Before I talk again about the treatment modalities, let's review very briefly what happens in the brain of a person who has Alzheimer's. In this picture, the left side is a normal, healthy brain. The right side is an advanced stage Alzheimer's. Let me tell you that, first of all, you can see a lot of differences between these two images, but of course, this person on the right is very advanced stage. People who are at the onset of Alzheimer's, they are at the very mild stage of Alzheimer's, you don't see these much differences. In fact, MRI imaging, if always could give us such a clear picture differences between healthy and abnormal, then we were okay. We could diagnose quite easily. The fact is that they can't. The aging brain is not that much significantly different than the imaging of a brain at the onset of Alzheimer's. What we know, however, is that as the disease, any type of dementia, there are about 7 different types, any type of dementia, including Alzheimer's, as the disease progresses, the cortex shrivels up, it damages the areas that are involved in the language, in pattern recognition, in speech, and so on. The shrinkage is especially severe in hippocampus, which is our memory gate. It is responsible to convert the short-term memories to long-term memories, and also on the cortex, prefrontal cortex, for example. That is our decision-making, our hub station of the brain. The ventricles as you probably see my mouse, the ventricles, these areas enlarge in advanced stage Alzheimer's, and they're filled by fluid. Usually they get enlarged as the disease progresses. What happens to the neurons? In fact, as a result of beta amyloid and tau protein, they create some plaques and tangles that sit under neuron. And basically what they do in a very simple language is that they isolate the neurons from each other. They destroy their connections to the other neurons. And once a neuron is isolated, is left alone, in fact, it dies. Neuron, if they don't activate, if they don't get excited, after a while, quickly they die. That's why that a person with dementia, neurodegenerative dementia or Alzheimer's, they lose their gray matter gradually. And for us who are the majority engineers, perhaps we understand when this picture better, that we know that synapses, which are the communication channels between the neurons, in a healthy synapse, they're like a healthy communication channel. When those tau protein create tangles, what happens is that these connections get destroyed. And therefore, there is no signal can be transferred from one neuron to another. So basically these abnormalities as a result of beta amyloid and tau protein, which tau is actually the main culprit, because in the presence of tau protein, beta amyloid becomes even excessive and creates tangles, creates plaques. Tangles are usually as a result of tau protein. As due to these two proteins, then the function of these synapses get destroyed, and the neurons cannot communicate with each other. And many medications try to suppress actually the tau protein in order to restore the communication between the neurons. But they don't do it that effectively, actually. And the question is, how about the non-pharmaceutical treatment? Do they, any of them, suppress tau protein or beta amyloid? As far as the medication goes, well, the most common medication is Aricept or donepezil, its generic name. And all the other medication, the majority, as I said, are from the same family. Not all of them, but the majority. Aricept is the most common medication that actually the majority of people who have dementia, they get the prescription of Aricept, either 5 milligram or 10 milligram per day. But its success rate, perhaps you don't know how low it is. It is 1 in 42, which means that 1 in 42 respond quite drastically, significantly, positively to Aricept. The rest of people are not lucky. Does it slow the progress or keep them plateau? Well, they claim that about 30% of the people show the slowing the progression, but the majority of people don't even respond. And even those people who respond positively, after a while, they may not respond anymore. So it is not that it is always long-lasting. Among people that I have seen with Alzheimer's, I would say about 200 patients that we see in our labs, about 30% of them discontinue Aricept due to side effect. So these information are good to know about medication, and that's why that researchers look at non-pharmaceutical treatments to see whether they provide a better option. And that is still into pilot studies to figure out really, do they have any benefit or not? And that is the list that I will talk. Let's start with TDCS and TACS. TDCS stands for Transcranial Direct Current Stimulation. TACS is for AC current stimulation. The machine for both of them is this. This is one of the brand machines that have been developed. One machine develops usually delivers both DC and AC, and um, the cost of it is not that expensive. It's about $10,000 US or $9,000 US. For me, it was about $11,000 Canadian with some electrodes and pads. The application area that these TDCS, TACS have been applied has been dorsolateral prefrontal cortex. You're a biomedical engineer, probably you know a little bit about the anatomy of the brain. Prefrontal cortex is right behind our forehead. Dorsolateral prefrontal cortex is on the side. It is still on the prefrontal cortex, but on the sides, either side. And temporal lobe, which is on this side of the brain, on each side. The frequency of application, it can be DC, it can be 10 hertz, 40 hertz, or random noise, or some people, very few people applied it at higher frequency than 40 hertz as well. The type of application, it could be cathodal or another type of configuration. There are two hypotheses behind how it works. One is that TACS directly entrains brain oscillation. By the way, I should say here that the amount of current that is being induced by TDCS or TACS is very low. It is not enough to stimulate a neuron, basically. It doesn't excite the neuron directly. What it does is that it increases the excitability of the neurons, but not exciting the neuron directly. And it feels very much the same as if you have gone to a physiotherapist and apply some electrical stimulation to your muscle. It has a tingling effect on the scalp wherever you apply. The second hypothesis is that TACS leads to synaptic changes with spike timing dependent plasticity mechanism. We are not sure exactly which of these two are occurring in the brain as a result of TACS, but these are hypotheses and we can indirectly investigate them. Another non-pharmaceutical treatment is visual stimulation. It has been done only on mice. It is basically flashing light into the eyes, flashing light at the gamma band, 40 hertz. Gamma band or gamma wave is the brain waves when we concentrate and we are solving a problem. For example, right now, if you are fully paying attention, you are generating gamma wave. This lady, I don't know exactly how to pronounce her name. I can say this lady, Prof. Lee. She's at MIT. Sorry, this is so sensitive. Okay. She's at MIT and she had done this study that saw quite significant improvement in terms of suppressing tau protein on mice. It hasn't been done on humans though. There is another light therapy this group apply. They put electrodes over the head, as you can see in this picture, and there are infrared lights, basically infrared electrodes, and the bandwidth is about 810 nanometer, total power less than 100 milliwatt. They published a pilot study in 2017. We reviewed it in our team. To be honest with you, I'm not convinced about this theory because they don't give it to the eye. They are giving it over the surface. We don't have photoreceptors in our neocortex. We have photoreceptors when the light is given through the eyes and given to the received by the visual cortex. So what does this light do with the neurons' excitement? They refer a lot to this lady at MIT, but that lady's work was totally different. She was giving the mice a flashing light through the eyes. not through the cortex. I know that they're running a large clinical trial at the moment. They contacted me in 2018, sorry. And I haven't seen any other publication from them. The other treatment could be transcranial electromagnetic stimulation, like the one that is shown in this picture. This is a good paper. Again, we reviewed it in our group too. You can Google and find it. It was published in 2019. What they do is putting these antennas basically over the skull and giving the electromagnetic stimulation. There is no feeling of it. It is similar as if you have, let's say you have about 8 cell phones and you put the cell phones around your head. It is similar to that in a way. What their pilot study was very, very limited in size, 8 patients, 2 months, every day, 1 hour a day. The outcomes, they saw some changes, however, in CSF, cerebral spinal fluid. They saw enhanced glucose utilization because they did imaging too. And also they saw some very mild cognitive improvement in ADAS-Cog. However, cognitive improvement was really very, very mild. ADAS-Cog is a questionnaire that is being used for assessing cognitive status of dementia patient, and a score of 3 or higher is considered as significant. Their improvement was about 0.7, something like that, which, I mean, the same patient, if you assess them in twice, they can have 1 or 2 scores of ADAS-Cog different without any treatment. That's why that I'm saying that they didn't see really cognitive improvement, but they saw suppression of tau protein. This is a treatment that I am interested to follow after the current clinical trial ends. So I went through those 3 before, and another 3 list of non-pharmaceutical treatment. These are the one that I use in my labs too. TMS and cognitive exercises and cognitive exercise plus TACS. Okay, this is our rTMS lab in Riverview. And what rTMS is it is basically quite a simple machine, actually. It has very large capacitors and a magnetic coil. You keep the coil winding. There are different types of coil. We use the coil figure 8. When we, this figure 8 coil, the winding is like this. As a result of this type of winding, the center of the coil has the maximum intensity. And what does this TMS does is that it, which is short, by the way, for TMS is short for transcranial magnetic stimulation. That R is short for repetitive. It uses a magnetic field to induce an electrical current. This electrical current is large enough to excite, depolarize, or hyperpolarize a neuron. We use it excitatory for the dementia treatment, but it has been used for treatment of depression for many, many years. In fact, it is clinically approved for depression treatment. And one of the protocols of depression treatment is to use it at low frequency, which is to suppress the neurons, in fact, hyperpolarize the neuron. But at high frequency, which means above 10 hertz, it is excitatory, it depolarizes the neurons. We ran the very first rTMS study as a treatment of Alzheimer's in US and Canada. You are in US, so it's interesting to know that rTMS was banned for research for quite a number of years, actually. It has been since, I think, 2013 that researchers were allowed to use rTMS again for research, for dementia research as well. I'm not 100% sure about the timing, by the way, but I know that a long time ago it was not, they couldn't do rTMS studies in US. In my pilot study, we had only 10 participants at a different level of severity of Alzheimer's. Therefore, we designed a crossover design of the study. Half of them received sham, the other half received active treatment. There is a sham coil and there is a real coil treatment. And the study was still double blind. And then we crossed them over, which means that the half that didn't receive real treatment on the second time, they received real, but they didn't know they were receiving sham or real. Just some quick result of the MoCA score before and after treatment. At the baseline, my protocol for the pilot study was 2 weeks every day. On the 3rd week, I gave 3 days a week. And on the 4th week, it was just 1 day. And as you can see, that they improved significantly on the 2nd and 3rd week, but again, they started to a little bit to lose it at the 4th week. So I thought that perhaps the duration was not enough. So we have a current clinical treatment for the TMS. It has been the largest in the world. When we got the funding and started, I saw a very recent study that had a similar number of patients compared to us. But we haven't published yet because our clinical trial is still ongoing. I can just share the protocol with you. It is a multi-center international with Canada and Australia. It is randomized, double-blind study, placebo-controlled. We have two doses of treatment, 2 weeks versus 4 weeks, either active or sham. And it is double-blind. They don't know if they have sham or real. But after the period of the study, which is 6 months, whoever who is in sham, we give them real treatment if they wish. The assessments are ADAS-Cog, which is the standard questionnaire for assessing the Alzheimer patients. We do it at baseline, then immediately after the intervention, then every 2 months and up to 6 months. So we are investigating the long-term effect too. The main parameters in any rTMS treatment protocol, number 1 is the frequency of the pulses. As I said, we use high frequency excitatory. We use it at 20 Hertz. Does it matter if it is 10 Hertz or 20 Hertz? I doubt it. Does it matter if it is 50 Hertz? I doubt that too. Why did we use 20? Heuristically, not a very strong reason. I know that if I go above 20 Hertz, people start to feel it will be more painful. Even 10 Hertz might be better, but to be on the safe side, they said above 10 Hertz, we did it 20 Hertz. The number of pulse and train of pulses is another parameter that one has to be careful about. In the current treatment, we use 1,500 pulses. It is delivered in the train. Each train of pulses is about 1.5 seconds. And the feeling of the TMS over the head is like a woodpecker poking to the head. It sounds like that too. I wouldn't say it is pleasant. No way, we don't lie to our volunteers either. And we give them some pre-treatment pokes to the head to see how bad or how good it is. Most people don't complain, but I would say there are a number of people who don't find TMS tolerable. About perhaps less than 10%, they find it, about 5%, they find it intolerable. About 10% would say it is painful, but they tolerate. About 40% they say it is not pleasant. And of course it is not pleasant. Every time I give it to myself, I get headache. But not everybody gets headache either. By the way, I don't give it as a treatment to myself. I give it in order to for the patients to feel better at the time that they come to our lab. The number of pulses, as I said, could be different. We give 1,500. In my pilot study, I was giving 4,000. I have tried it again, 4,000 at the maintenance studies, but again, to be honest with you, I haven't seen much difference. It seems it doesn't make really that difference. Perhaps the duration is most important. So treatment dose could be the duration of the days that a patient is receiving. Researchers have given 2, 3, 4, 6 weeks every single day. The bold numbers are the one that I have. We are trying to do 2 weeks and versus 4 weeks. In pilot study, ours was 3 weeks, basically. There is an Israeli group who has given 12 weeks in a row, which is 3 months, every single day. And then another 3 months, 2 days a week. This is huge. The burden of such a protocol is huge for patients. I really don't know how those patients go to the center, how they recruit that many patients. They haven't had that many. There are about 45, 50 subjects. But protocols is demanding because every patient has to come with somebody to the lab and then receive the treatment as well. The target area is another important factor in rTMS treatments. We apply it again to dorsolateral prefrontal cortex bilaterally, both sides excitatory. Why? Well, it has some reasons. It is, as I said, prefrontal cortex is the hub station of the brain. It has projection to every single other part of the brain. It can probably activate the basal forebrain through cholinergic effect, and it increases cerebral blood flow, glucose metabolism in this stimulated, and by cholinergic effect, probably in the remote brain regions as well. And it can enhance brain synaptic plasticity. The Israeli group applied it also to temporal lobe and parietal lobe. And when they applied to parietal and temporal lobe, they matched it with some cognitive exercises too. For once, out of curiosity, I applied it to temporal lobe of a patient, of a volunteer, and she started to hallucinate. And I stopped the treatment too. And she wasn't complaining. She said it was such a nice hallucination. She was hallucinating a church, a choir that she was singing in it. And she was aware that it was a hallucination for her. So I stopped, and we only give the dorsolateral prefrontal cortex. So now how about cognitive exercise? Haley, how are we doing in terms of time? Please let me know.
We are at, it's 5:38. We're doing good on time.
So 20 minutes, okay? I wrap it up. Okay, about the cognitive exercise, well, you have all heard about use it or lose it for the muscles, right? So many people believe that it applies to the brain too. Exercise your brain. So when I started this research, my question was that, is it a fiction or fact? Just as I started in 2018, I was in the middle of the first pilot study that a paper was published by this gentleman, again, I'm not sure if I can pronounce his name correctly, Stojansky. His first name is Bobby. I'm going to refer to him as Bobby from the rest of the talk. He said in his paper that there is absolutely no benefit of doing brain exercise in general. Not in healthy, not in Alzheimer patients, not in dementia, in nobody. It does nothing. No near effect, no far effect. Near effect means if you get better in the task that you are being exercised. Far effect means you get better not only in the task that you are doing exercising, but in the independent tasks that are similar to your exercise. He said absolutely no near effect, no far effect. And he had quite a good number of young students participating too. Read his paper. It wasn't a bad study. He just said there's negative results. It's a good study. So question, is Bobby right or not? As I said, I was just in the middle of developing this brain exercises when his paper was published. In this app that is now on App Store, I called it Mind Triggers app. That was the only meaningful name that was available. It has 7 games. Each game has so many different levels. It has been designed based on actually our own observations, my observation of patients who have been visiting our labs, as well as my own mother, that as we tend to grow old, we lose our associative memory. So the majority of these games focus on associative memory, left-right brain connectivity, and so on. Because some functions are exclusively on the left, some functions are exclusively on the right, and they are being relayed through our relay function, corpus callosum in the brain. It also works, there is a game also that on spatial cognition. One of the associative memories like that we show 2 items that have no relationship with each other, and we train them to make an association between a geometrical shape and an animal. And then at the end, we test them that to see how many they remember. And it has so many different levels. Another game is just visual memory. This is very similar to the games that are available online for free too. And we ask, okay, the word chicks, did you notice where it is? We read with our left brain, we see with our right brain, and we recognize the pattern with our right brain. So again, this is a connection between left-right brain and enhancing working memory. And this is a spatial game that I love that. Many of our participants hated it because it's challenging. Through the trials of this game, we force people to rely on geometry to find a target. We remove landmarks, cues, gradually one by one, and force them to remember the geometry of the environment. So we investigated the effect of cognitive exercises with or without TACS. Group 1 only received cognitive exercise. Group 2 received cognitive exercise plus TACS at the same time. I didn't have a group for only TACS. You can ask me during the question as why not. The exercises was that app that I showed you, and primary outcome measure was an independent test. Secondary was a custom design test that we had. We investigated, therefore, the far effect, not near effect. And all of our sessions, by the way, were tutored. For dementia, for healthy individuals, they could exercise on their own, but I'm not showing you those results. I'm showing the results of dementia patients only. And all of the dementia patients had a tutor, a dedicated tutor for the duration of the study. So group 1 who received exercise and TACS were 19 people, and group 2 were 10 people, almost age matched, MoCA matched. They had only brain exercise. I know that they are not matched in terms of size. Again, I leave it for the questions as why they are not. Not that we planned not to be, but the reasons I can explain later. The protocol was 4 weeks using brain exercise every single day with a tutor. And assessment baseline, post-intervention, and follow-up a month after the post-intervention. We repeat this protocol every 4 months for patients. I have had patients who come back to the lab for the last 2-3 years to receive the same protocol, but I'm not showing those results either. The assessment MOCA WMS, again, it is a very standard questionnaire for people with dementia. And the secondary outcome measure was a spatial orientation. Protocol for the TACS, we used 1.5 milliamp sinusoidal at 40 hertz. Again, why 40 hertz? Because I said we tended to give gamma band stimulation, because that's the brain wave when we focus and we start learning and we consolidate the memory. We applied the active electrode over the left dorsolateral prefrontal cortex, and reference was over the contralateral area. And delivered it, of course, simultaneously with cognitive exercise. Assessment, as I said, was a WMS. I'm going to go quickly over this because it's just a standard assessment. You can Google and find more about it. The spatial orientation test, however, was something that we have designed in our team. It is a virtual building. It has no landmarks, no clues anywhere. It looks exactly the same from everywhere. And it has 2 stages. One is localization of a target from outside the house, and the other one is to go inside the house and find the target. However, none of the MCI AD patients can go inside the house and find the target. Basically, they are totally lost in it. That's why that I use it as a diagnostic test. But I used only the first stage, localization, as a monitoring tool. And what it is that we rotate this virtual house 1 full cycle. One of the windows has an X mark on it. And when it stops, after 1 full rotation, I simply ask, where is the target? Where is that X? There are 3 options: left side of the building, right side of the building, or back of the building, isn't it? It's so simple, extremely simple. And still, Alzheimer patients' accuracy in this one is very, very low. It's by chance saying the correct. MCI people, mild cognitive people, can do it better, but their accuracy is about 60-70%. Okay, so here is some result. Blue are the ones who received TACS on top of exercise. Orange are the ones who received only exercise. As you can see, both groups improved significantly from baseline to post or baseline to follow-up. So both groups almost similarly. The amount of change was almost similar from baseline to post. However, the difference between the 2 groups is at the follow-up. This graph shows it better. This graph shows the changes respect to baseline. Blue one and orange exercise one, as I said, both more or less the same improvement, both significantly. But the one who received TACS not only stopped during the follow-up, because we stopped for a month, the duration of the study was just 1 month. Not only they didn't decline or stop, but also improved further. The group who received only brain exercises at the follow-up, they were more or less the same. They didn't improve, they didn't decline, but the difference between these 2 groups at the follow-up was significant. In terms of a spatial cognition orientation, Again, it shows that that hexagonal room is that game that people hated it because it was challenging. That had a positive impact on an independent assessment for their spatial cognition. They did improve significantly from baseline to post. But THCS didn't play any role here, it seems. It's interesting. Of course, my data is samples is small, but interestingly, TACS effect was more on the memory aspect, but not on the spatial aspect of the enhancement. So in summary, more than 90% of our participants, of that 29 people, more than 90% improved significantly. 10% of them didn't improve, but they didn't decline either. An application of TACS simultaneously with brain exercise seems to enhance the positive effect of brain exercises, and it helped them to last longer. So the main conclusion, I believe, the key for brain exercise to be effective is that it is in its mode of delivery. Remember, Bobby said nothing is effective, no near effect, no far effect, no nothing. I would say because the delivery is important. If you let people to do it on their own and they have no desire to improve, they don't improve. It is very much like people want to improve their muscles, and some people go buy treadmill and put it in the basement the first week, enthusiastically every day go to the basement and exercise, and then after a few days forget it. They forget about the basement completely. The second group go to the gym and exercise. They need to be motivated. The third group not only go to gym, they hire a personal trainer. Which group you think that they're benefiting the most? People who go to gym and hire a personal trainer, of course. The same applies to the brain, in my opinion. It is the tutor. You may call it placebo, so do it, be it. I don't call it placebo. If you want to investigate if it is placebo effect, we have a very good, one of our assistants, his name is Mari. We called it Mari's effect because she was so passionate and bubbly and everybody loved her. If we want to investigate the placebo effect, I have to have Mari to sit, chat with our participants for a month every day and see if they improve or not. I'm certain that they won't, but it is important to have a tutor. So again, I would say against what Bobby claimed, I would say use it or lose it completely applies to the brain. And the key point is to keep it dynamic. Bobby's experiment was so boring. Read his paper. It was really boring and repetitive. There was no that much level, no variety, nothing. These Mind Triggers app has 7 different games with so many different levels. So it is important to have the exercises dynamic and challenging. Exactly the same way that you have to keep the weights of your muscles dynamic in order to gain from the exercise. That's the acknowledgement of the funding. NSERC Riverview Western Brain Institute that has funded the current rTMS treatment, and people's, especially one family's generous donation, which made this TACS brain exercises possible to do extra. And also AgeWell funded me for one development of the games too. And last but not the least, thanks to our volunteers, we have had wonderful volunteers, as well as my mom, my late mother, who was inspiration for all of these studies from 2009 till now. And finally, every researcher is as good as his or her trainees. And I have been lucky to have so many talented young people, brilliant. I learn from them, and a lot of volunteers too. Of course, this is just a picture of people who could attend that launch appreciation that we had on that day. The team is larger than that. Some of them have left the team already too. And I would be happy to answer any question if you have.
It looks like we had one question in the chat earlier in the presentation. We can go ahead and answer that one first, just because they asked first. So this is from Jack. He says, as I read in literature and heard it from Dr. M. Oz, who has a medical TV program on Fox TV, there is a rare number of Alzheimer's diseased people in India, and they claim that is because they have a great deal of turmeric in their diet. Is that true, and what are your thoughts on that?
Good question. Dr. Oz. You watch Dr. Oz, really? And he doesn't get on your nerve? Really? I'm amazed. Yes, turmeric, they say it has a positive effect, but you know how much turmeric you should eat in order to have that? I have talked about that actually in my second TED Talk. How to age with a healthy brain. Yes, India has one of the lowest number of Alzheimer's, but how much can you trust that stat really? That's number one question. Number two, what is the life expectancy in India? Do they get old? Really? The life expectancy in India is pretty low, much lower. It is not correct to compare India to Canada or to Australia. If you want to compare, you have to compare Canada, Australia, and US together. Europe is a different too, but you have to compare countries that have the same life expectancy. Turmeric, yes, in animal studies have shown that it is beneficial for to fight against Alzheimer's, and so is cinnamon. But again, for cinnamon to be effective against Alzheimer's, you have to eat at least, I think, half a cup, or how can you eat half a cup? And it is toxic. It has a toxic actually component in the cinnamon that if you eat 1 spoon of it is okay, but more than that, it is not okay. And please don't listen to Dr. Oz.
Next, we have a question from Brian asking, do you plan to study ACS at different frequencies?
If I get funding, yes. As I said, I have been running that with donation. I don't have any major funding for it.
Awesome.
Zahra, I have a question, if possible.
Go ahead.
Okay. Hi, Zahra. That was very nice talk. This is EVestG here. So my question is regarding the earliest report that you mentioned, and any of these treatments has caused a decrease in the tau protein. I was curious how they measure the tau. Are we talking about the autopsy samples, or this is a technique that I don't know of?
They got the CSF.
Okay.
From there, they measure. You're talking about the magnetic stimulation, right?
That was one, and
yes.
then the other one, also the light therapy that you mentioned. You know, in mice I could understand, but you know, the results for humans. So it is the CSF, but you know, the pathology of CSF and tau is a little bit different. That's what's going on inside the brain. So those kind of things, you know, would be best looked at if autopsy after you know, the termination of treatment, if possible, or when the patient passes. But anyway, thank you very much. That was a very enlightening.
For sure. Just one clarification. The light therapy that was applied to humans, that wasn't really, in my honest opinion, it wasn't a very good study. They did not measure CSF. They did not have any imaging. They just measured the EVestG, and it was only 5 patients. And even based on the EVestG, the result was not convincing at all. But I found that magnetic stimulation, however, like the antennas over the skull, that was quite a good study. They did a thorough study with imaging and CSF measures. Yes.
I will look it up. Thank you.
Sure.
Olu, do you want to ask your question? I saw you have a question here.
Oh yeah, I've been reading the questions from the chat.
Right, about the combining, yes, that's Zainab, my postdoc has asked that, combining that flashing lights and TACS together. Whether I want to do that, you know, it may sound easy to do, but recruitment is not easy. I was referring to that some of you may even ask me, why don't I have a TACS group alone? Or why didn't I do randomization? Why didn't I include equal number in exercise and TACS? I didn't do any randomization. I can tell you why. The main reason, the main limitation that we have, aside from money, actually money limitation. The main limitation is recruitment, and also giving them a false hope, maybe. I could, for a study that I'm running with the donation of people, some of the volunteers, participants even donated, I feel obligated to give them real treatment. I can't give them placebo. I can make myself to do that. Unless I have a major funding and I can pay participants to be in the randomized. So far, the 29, we have had more than 29, but I still showed you the result of 29. About 35 people that we have had. And these 35 are coming back to the lab for, as I said, for the last 3 years for repeated treatment. They all choose what they want. People who cannot tolerate TACS, we give them only exercises. That's it. That's why that there is no randomization. So otherwise, I'm convinced that TACS enhances the result, and I offer it to all of them. But not everybody likes to receive that tingling effect. And as a matter of fact, even for myself, I felt TMS was easier for me than TACS. Some people don't even feel it, but some people feel it and it is annoying. For me, who has a very sensitive scalp, it gives me worse a headache. So I couldn't receive TACS, for example. I had people, even male, female, that didn't like it at all. So we didn't randomize, they went to the other group. So Zainab, to answer you, yes, I wish I could, but it's not easy to have people in different groups, and especially when you're running them with their own money.
Thank you, Doctor. We have another question from Olu. He says, I had a question about the timing of TACS. Is there any evidence to suggest that stimulation before training would work better than stimulation during training?
To be very honest, I cannot remember. I remember I have seen papers on that. That's something that could be investigated. Whether it is better or not, my neurophysiology is not at the level that I could answer that, really. Don't forget, I'm an electrical engineer, which educated myself in neuroscience by myself. I understand, I read a little bit of neurophysiology, but I cannot answer that question. But I remember that there are papers that have investigated whether in human or not. That I am not sure at the moment. Good, very good question. I'll look up into that to look for it.
And then I had a question as well. I was wondering how did you confirm that the spatial orientation test with the virtual house was like a valid diagnostic tool for identifying Alzheimer's? And was this a topic of a separate study maybe?
Yes, for the as a diagnostic tool, we have published too. I have had about 378 participants across different ages, which out of the 378, about 250 of them were age 50 plus. And we have had quite a number of Alzheimer patients too, which the publication doesn't show all of the Alzheimer MCI peoples. We are in the process of updating the result, publishing it too. That is, it's a custom made, it's my design. That's why I put it as a secondary outcome measure. I have a faith on it. It can diagnose, it can separate people with Alzheimer's, people who are having vascular dementia mixed with Alzheimer's, but it cannot identify some other types of dementia. For example, frontotemporal dementia. Those people actually are very good spatially. Their result is like healthy controls. So my test fails for frontotemporal for sure. Lewy body dementia, also similar to Alzheimer's. I cannot separate them. But it can identify these people separated from the healthy people with a very high accuracy, very, very high accuracy. The localization, however, is I use it as a monitoring. As I said, we ask them where is that target. The answer is three answers, and then I also ask them which corner of the wall is it? Is it on the left corner or right corner? There are just two answers for that. So a score of 9 is being given, maximum score, something like that. And I compared the score from baseline to post to follow up. And it seems that hexagonal room game that we were forcing them to learn the geometry, it seems that it had an impact on their spatial orientation. But the number is low, and I can be as certain as the number of my sample size.
Thank you.
There is someone else in the chat who said, this is Jordan. Jordan says, hello, I'm wondering if you have any advice on how to help someone with dementia. My grandma lives with me and she has dementia, so she cannot live on her own. We have tried crossword puzzles and music. She doesn't do them and she turns the music off. She's already on a lot of medications for her heart. Thank you.
Sure. We do offer these exercises virtually as well since the pandemic. Since the pandemic started and we went to lockdown in March, we started to offer the same tutored brain exercises through Zoom to people, to individuals. And it is still running. I would be happy to have your grandma enrolled too, as long as she can understand, comprehend verbal instructions. And there are some requirements, of course. They have to have an iPad version 14, iOS 14 and higher. But as long as there is a Wi-Fi connection and iPad, then we can have those classes. The classes are free. I mean, the sessions are free and is every day. Other than that, I would say try to engage your grandma with some activities, physical activities for sure, know that, as well as cognitive activities, anything that you can make her interested. And you have to keep changing that because they change. The problem with treatment of this dementia, neurodegenerative dementia people is that they decline, and after a certain age, no matter what we do, they speed up in their decline. As I said, we have had patients in our program some of them even for 5 years. Some recent ones have been with us for 3 years. And no matter how much we try, we slow down their progress by repeated treatment for the first 2-3 years. But after that, it seems that we cannot defeat the neurodegeneration. They speed up. And that's quite sad. We prolong a little bit, we slow down the disease a little bit, but not the way that I wish we could.
There's also another question. Jack says, we have a research group here who are studying applications of nanotechnology for prediction and treatment of Alzheimer's disease. I wonder if you've heard about such research.
No, nothing about it. I would be happy to learn more if you can enlighten me.
And then I actually have a question. So how did you, I might have missed it or not quite understood, how did you simultaneously administer the TACS and the cognitive exercises? Because right?
Yeah, we start with the TACS first. We put the electrodes and then turn on the machine and doing it. Then do the exercises. That's it. TACS doesn't prohibit you to do anything else. You can work. In fact, there are even commercial TDCS on Google as cheap as $150. They say that apply it to yourself when you have exam, and it makes you smarter.
Oh, wow.
I'm not recommending them. They're not medical devices. Their safety is not being tested, but there are on Google and Amazon, you can buy them. None of them are TACS in the market though. TACS is only for research too. And that's another thing, that if a person can tolerate TACS, but find it difficult to focus on the exercise, we stop and we put them in the exercise only group. Because the whole purpose of this TACS simultaneous with exercise is that they should be able to do exercise simultaneously. If they can't focus on it, if they find it too distracting, we change their group.
Okay. We actually just got another question. Can you tell us more about the music therapy treatment?
Well, that is, I haven't seen any published research about it, but there are music therapy being offered by some nursing homes and some programs that offer daily programs to dementia patients. And they all claim that it helps. But I haven't seen any scientific research about it. There might be. I haven't looked that carefully, but I haven't seen any.
I know this is a journal club topic. A couple of weeks ago, we talked about music therapy, but it was geared specifically towards Parkinson's disease and gait improvement using rhythm stimuli. So while that doesn't necessarily relate to Alzheimer's, I hope maybe that answers your question. I can drop the links to those research documents if you guys would like.
I'm pretty sure that you must, I mean, not sure, but you probably have seen that ballerina who, when she heard the music and she started to dance. Haven't you seen it on social media everywhere? That's fantastic. I saw a similar thing on my late mom too. And a couple of other patients, they respond so drastically to the music. However, again, this is just anecdotal observation, my observation from my mom and the other patient. The effect was only once, the first one, not the second time, not the third time, even to the same music.
So I just put the link to your research website in the chat. Does anyone else have any more questions? I know we're at 6:14, so we can go till 6:30, a little longer if anyone wants, but is there any other unresolved questions from anyone? No?
You know, I did have one more. You mentioned that rTMS was banned in the United States for a period of time. I was just wondering what the history there was and why it might have been banned.
I used to know it. Maybe I'm showing old age signs or Alzheimer's. I cannot remember why. But for a number of years, in fact, I remember Dr. Laura Boyd moved to Canada. She has a physiotherapy background and she still applies it to stroke patients. She moved from US to UBC, who is still there, and it's very active, very well known. And just because she wanted to apply rTMS to stroke patients. Google it. Google knows all of these. I have to Google to remember too.
Thank you.
Any other questions? I know.
I have a question. So for students who are interested in getting involved in this type of research, how would you advise they would proceed?
For dementia research, you mean? Well, if you're talking about your undergrad, it seems that you guys have quite a good program and with neuroengineering concentration, right? And I would say go in that concentration and get enrolled in summer projects. And by the way, if by any chance you can travel to Winnipeg, you're most welcome to join us over the summer too. I would love that. I would love to have, as I said, new, passionate, enthusiastic students. Online too, if you are very interested to work with Alzheimer patients, you can be an assistant to the work as a tutor.
Thank you. And that was a very great talk. Appreciate it. We learned a lot.
That was, thank you very, very much. I think we have one more question. I don't want to miss it. Right now, real quick for all, I know it's not just UIC people, obviously, but for everyone at UIC, just make sure if you haven't already, sign up for our mailing list, our Google Calendar, just that way you don't miss events like this, right? And the question was from Mari. Mari asks, Dr. Moussavi, have you considered including dance as a part of your studies with Alzheimer's?
I'm laughing because this Mari is the same Mari that I said Mari's effect. And she's a professional dancer. She did offer dance to our Alzheimer patient in 2000. Mari, you tell me what year. It was 2015, maybe. Not as a research, but we offered it as a side program to our patients. And about 5 couples participated in that dancing, and Mari was teaching. I participated there. And at some point I was watching the group. It looked like a bunch of robots, very stiff, trying badly to follow Mari's lessons for salsa dancing, but you don't know how much they enjoyed it. In fact, we have a videotape of them too, that they enjoyed so much. Whether we can have it as a research, again, the same answer that I gave to Zainab. I love to have investigate all of this scientifically, but investigating scientifically means we have to have enough number of people in one group, and we have to have a placebo group, we have to have a controlled group, as well as money. So that's the answer. I wish. And anytime that Mari, you are interested to offer the dance class, by all means, I'll help you to do it. I guess after COVID.
All right. Any other questions? I know every time I ask, everyone asks a question. So I just want to make sure we get all the questions asked. This is your one and only time to ask the researcher herself, you know?
I'm easily available. If you want to talk to me, just send me an email. And especially during this COVID time, I welcome Zoom meetings, individual Zoom meetings too. It keeps us sane a little bit.
I think that's it. Again, Dr. Moussavi, thank you so much. This was an amazing presentation. And like I said, so for all the participants still, I guess, with me, everyone will be getting the link to this sometime later. I can't guarantee today. I also can't guarantee tomorrow, but you will get it, I promise. And then I think that is it. Dr. Moussavi, thank you very, very much.
Thank you very much for inviting me. It was my pleasure. Thank you.